Hi. Okay, I think we're live. Max, we're live.
Yay.
Hey, everyone.
Let's see.
There's some new people here who I don't think I've really connected with. I don't know who they are. So everybody, hey, everybody, welcome, ninjas. I'm Kareen. This is Max. If you don't know me, I'm Kareen. You can chat with us here. There's a little chat window on the right-hand side of the screen. I think it's on the right-hand side of the screen. Hi, Paul. Hey, everyone. Yes, thanks, Max. So, what'd you say?
Being helpful.
Thank you. It's good. It is helpful. Okay, so what I was thinking we could kind of do, guys, so we have a small group here. So like, if you have questions or whatever, you could totally have it be like a more of an intimate session. You can even ask questions with your microphone on your laptop if you want to. What I was thinking to do is that Max is going to present, and Max, you can tell me if this is okay with you or not. Max will present. If you have any questions during his presentation, you can just push them right in the chat, in the public chat. If it's something that you want to save for like a Q&A at the end, there's actually at the top of the window of the chat window, there's like a chat, there's a Q&A, polls, handouts, whatever. You can actually click the Q&A button, and there'll, you can just put your questions there, and then people can actually vote on them, but it doesn't matter. We can just go through the questions but if anybody else votes on them or whatever, we can prioritize based on that too. So where's everybody from? I feel like I know some of these people. So there's some people I don't know. Estonia, Minneapolis, Calgary. Oh. So do you know the Menome guys? The guys, Mike Morley? Yes, Michael Black, Elena. Okay, well, I'll have to connect you with them because they're in Calgary too. Really cool guys, and they're super graph nerds. I'm in Philadelphia. Max?
I'm in Round Rock, which is middle of nowhere. Not really. It's next to Austin, but it's
everyone's like, where's that?
It's a nice place where you can buy a big Mac mansion for like nothing. So
that's funny.
It's like if you're tired of living in a tiny condo, move to Texas. You get a lot of real estate here.
Everything's bigger in Texas, including the data, big data. No, just kidding. Jennifer is here too. Jennifer Reif is here. If you guys know her, she's one of our colleagues on the developer relations team. She's amazing. Hi, Jennifer. So if you are interested in asking a question live and you want to be added to like a microphone or a video, you can definitely do that. You could do it now or at the end. You could just message me privately. Just be like, I have a question. Or you can use the little hand thing. There's a little hand icon on the chat window on the bottom next to the emoticons and stuff. So, okay, I think we can get started, I think. Good.
Okay, so I always like to start every single presentation with the same stuff. So if you've seen this 1,000 times and you're bored of it, that's fine. We can skip it. Otherwise, I just want to make sure everyone is on the same page. So let me just hit play, and we'll go through this. All right, there's my giant head. My name is Max De Marzi, Neo4j field engineer. I've been at Neo for 8 years almost, or something like that. I obviously keep a blog at maxdemarzi.com, and if that's something you haven't done yet, which is start blogging about technical topics, I highly recommend it to everyone. That's one of the reasons I got hired at Neo4j, and just being able to find your voice as a developer, as an engineer, and just talk to people and say, hey, I'm learning this, I'm learning that, and see how neat it is. And remember, even though you may not be an expert at something, there's always going to be someone who is one day behind you in their learning process. So if you can kind of speed them up by teaching them something you just learned, it helps everybody. It helps the community anyway. Follow me on Twitter, Max De Marzi. What's that?
Max loves blogging.
Well, it's something to do. Right?
You love blogging.
No, it's not.
You're also
people always think that you have to be good at. No, it's just you just have
blog.
to just do it. I've done 160 blog posts. My first few sucked. It doesn't really matter. You get started and you find your voice sooner or later.
Yeah, and if any of you guys are blogging anything, you can send it to us. We can either publish it on the Neo4j Medium. We might be able to publish it on the neo4j.com blog. Or we can also post it on the community site. So we have a content section on the community site.
Yeah, don't feel like no one's going to read your blog because nobody knows who you are, or because you're just getting started. So there's always ways to get your content out there through us or through other folks.
Yeah, and we also feature it in Twin4j too, if you're blogging about anything. Oh no, sorry, Twin4j this week in Neo4j. I'm like, let me not use that.
Well, it's okay. That's the smartest thing. But yeah. All right. And then a lot of the stuff I write is open source on GitHub. You can find all kinds of things on there. All right, let's keep going. Skip the agenda. Property graph model. You guys already are ninjas, so you know this. This is how we model the world, do nodes and relationships. Nothing really has changed in 4.0 with this stuff. You still can't do nested properties. You still can't do anything too fancy, like relationships to relationships or weird stuff like that, or single-sided relationships. None of that stuff has evolved into the product just yet. On my dream list, but hasn't happened. All right, and most of you already know SQL, some kind of mess that looks like this. And the problems there are obviously the join queries that always kill everybody because you have to do these every single time you query a relationship. And the big thing about Neo4j is that we can skip all that by connecting the data by pointers, right? We always say that relational databases suck at relationships because this is a 40-year-old model. I mean, SQL started in the 70s and it's 2020, for God's sakes. It's been a long time. There's better ways to do things, but we're stuck with the old guard still. And we're still stuck with this SQL language that was built around set theory and handling sets of data, which is great if you're an academic or if you're into numbers, if you're an accountant, if you're number crunching, if you're a tax person, fantastic. But in our world, it's more about social. It's about how things are connected. The deeper things go, the happier Neo4j tends to be. The more highly connected things are, the happier we tend to be. So we have this NoSQL stuff. It's been around for, what, 10 years now? Most of them kind of stayed away from relationships. The only ones that really jumped onto that side are the folks at Neo4j and the other graph databases. And there's a good number of vendors in this space now. There's 10 or 12, I would say, viable vendors that you can use for your graph database projects if you wanted to. And the big difference from relational and graph is just we store data differently. There's no magic. A lot of people say, oh, graphs are really just a different way to query. You have a different language on top of traditional relational layout. And that's incorrect. If you put a graph language on top of SQL Server, it's not a graph database. You just let it speak graph. It's like learning Italian when you're not Italian. It doesn't make you Italian all of a sudden. You just speak the language, right? It's not a graph database. So what does that really mean, though? It means how we store the data is different, right? And the real way we store data is in this horrific double linked list relationship layout setup, where the properties are in a single linked list, so they're easy to understand, but the relationships are mixed together. Every relationship knows the previous first node's relationship and the next relationship, as well as the second node's first and next relationship, which is a horrific way to understand it. So I don't recommend people think of this model in their head because it's not very useful. And also the storage layout kind of gives you a hint of that, how that data is laid out. But the better way to abstract Neo4j and how it works is in this next slide, which I always say is the most important slide you ever need to see in order to understand what a graph database is all about, which is this slide. And you might have seen it 1,000 times, but really this is all you need to understand to see how graph databases work, right? We have two join arrays, one of nodes and one of relationships. Every array has different types of relationships. I'm sorry, every node has different types of relationships that are connected to it, separated out. And each type is two lists of incoming and outgoing relationships. There's also a third list for self-referential relationships. So you can say, I like myself. But we don't really talk about that because it's kind of weird to even see that in your data models. We definitely allow it, but it's weird to see that. So there is a third list, but ignore it for now. So we just have two lists, incoming and outgoing, really. And these lists contain relationship pointers. They're just ID numbers that point to the relationship array. And they say, all right, from this node, I'm going to jump out to a relationship of some ID, And then from that relationship, I'm going to get the start or end node, whichever one I'm looking for, whether I'm going in the incoming relationship or an outgoing relationship side. And then I'm going to jump to that other node and then get some key value pair or continue my traversal from there. And the magic here is everything is done by pointers. So there is no finding a B tree and walking down the B tree 7, 8 layers down, finding the record and matching it to the physical location on disk or where that record is and kind of going from there. All that, it gets skipped because we can use the actual relationship IDs, our physical pointers to where the data lives. This is one of the reasons why we're kind of limited to storing data in a single graph, in a single system. Now with 4.0, what you're getting is the ability to shard data. But the way we're sharding data is you have multiple graphs, none of which are directly connected to each other. So you don't have relationships between graphs. What you have instead is data that is copied. So we can say, okay, I'm going to take this node that represents a username, and I'm going to save them in 2 graphs. So I can kind of find the user's friends and then use that and use those IDs to look up something about those friends in a second graph, in a second shard that we're calling it. But it's still all connected physically in one graph at a time. That's really how we get our speed. Okay, so why is this important? What is the secret to Neo4j, right? And it's partitions, right? We have kind of pre-joined everything you have in the database into these lists by node, by relationship type, and by direction. So that if you want just something really specific, these person's friends, you can go find me the user node, go to the friends relationship type, and get me the outgoing or incoming of this one particular node. You don't have to look at these giant tables of billions of records long that you would in a relational database. And especially if you're doing something like recursive queries, those can get pretty hairy in a relational database, and eventually you blow out your heap and you're out of RAM, and then you're dead in the water. Well, Neo4j doesn't care; it just keeps traversing. The other thing to understand about Neo4j is that it doesn't look like it when you show you Cypher queries. It looks like, okay, this is doing a pattern matching, right? So it has to find the entire pattern before it continues. The hint there is that it finds the entire pattern. So all of our queries are depth first, right? Think about that. So we're finding one node, a starting point, and we're traversing out until we finish the entire pattern, and then we go find the next pattern for the next node that we may match on. So it's not that we're doing find all the users first, then find all the transactions, then find all their friends. No, it's one node at a time, depth first. That's why we're able to do some of these queries. If we try to do everything breadth first, we would run out of memory trying to keep track of everything that's going on. So that's another thing to have to think about in your head when you're doing this. Everything is depth first in a graph database, versus in a relational database, they tend to do everything, what do you call it? Breadth first, because the joins let you filter sets of data at a time. But they have to keep these sets of data in memory at a time while they're doing it. But we don't play that game. We do one at a time, what they call tuple at a time processing. And they look down upon this. They say, oh, tuple at a time, that's 1960s, that's 1959 technology. That's the old way of doing things. Nobody wants to do that anymore. But when you have massive quantities of data or these crazy long paths, tuple at a time is the only way you're actually going to get a result. The other ones are just going to be blown out of the water because there's no more memory to handle the breadth first, because you have these barriers that they have to go through. It's just not going to happen. Anyway, that's a long rant about relational databases. They are not the same thing. Putting a graph language on top of a different database does not make it a graph database. Hopefully that is clear. If you have any questions, ping me about that. Now, this is not magic. There are some queries that we're not optimized for and we absolutely suck at. And that's queries that look at a single model, a single property, that don't do any joins at all. They're not going to be done great in Neo4j. We're not optimized for that. We're optimized for hopping around. In fact, our property store is one of our weaknesses, where it's fairly slow to read a property from a node or from a relationship, something we're actively working on to try to improve in the next couple of years. But what am I talking about? So what is the average height of all the Hollywood actors, for example? So this is a query where you're looking at a single model, an actor, a single property. Now, the way Neo4j stores data, we don't know we don't have a little space for the actors so they can all live. Instead, we realize node 1 could be an actor, node 2 could be a movie, node 3 could be a play, node 4 could be a commercial, node 5 could be a director. You got to jump around until you find these actor nodes. And now you can use labels to make that easier, but you're still jumping around in space and memory looking for these actor nodes. And then once you get to the actor node, you have to find the height property. And if you remember, Neo4j is a dynamic relational database, which means you can add any number of properties to any node, and they can be of any type. So a height property for one user might be in centimeters, it might be in inches for another user, it might be a float for one, it might be a string for another. The graph itself doesn't care, which makes life kind of painful. And also, we don't tell you where we store that height property. It could be the first property on the list, it could be in the middle, it could be at the end. So we kind of have to traverse this single linked list of properties for each individual node until we find the height property and then kind of grab the value and go from there. So for those queries, not so good. A better system would be a relational database that keeps all the actors together in a single table, or even better, a column store that keeps all of the heights of the actors in a single column together. Better performance for those kind of things. But if you want to know how these actors are connected to each other based on the movies that they acted together in, like a 6 Degrees of Kevin Bacon type of query, then we're awesome at those kind of queries. And it all works as long as you drink the Kool-Aid, right? You have to stop thinking of your data as tables, and you have to really think about them as graphs. And that's the biggest thing we try to get from people is you got to stop thinking in the traditional sense, and you got to start thinking in the graph sense, where everything is a graph. Everything is connected. Everything is about relationships and how you traverse from here to there. And as long as your data model and the data you're working with, queries you're asking, are graphy in nature, you're going to find a good time with Neo4j. But if they're not, then you should use a different solution, a different technology. We're not the best at everything. I'm not going to say we're never going to get there, but it's going to take a while before you can say, oh yeah, Neo4j is the perfect database to use for everything. That's kind of a stretch. I mean, we may never get there, but we are great for highly connected data, which we keep saying. All right, so modeling. We talk about modeling. There is no third normal form in graph databases, which means there's no right way to model data. There's plenty of wrong ways, but no right way. So you kind of have to get creative in what you do. What I like to use is arrows. So hopefully all of you who are ninjas have seen this tool. It's written by one of our developers a long time ago. It's pretty bare bones. It looks kind of barren, but it's simple, it's fast, and it doesn't run out of ink, right? The markers sometimes do. They're hard to read. I have terrible handwriting. I should have been a doctor. So it looks like a mess when I do models on the whiteboard. So that's why you just bust out arrows and use a projector and or a TV or something, and we have better looking models. So we have this concept of nodes, and they can have any number of relationships, obviously. The limit is 32 billion, technically, 34 billion, something actually, with the standard edition, and then it goes up to like 500 billion with the enterprise edition if you set the high limit on, but it's not on by default. So that's fine. You can have many relationships between the same nodes. That's not a problem. Friends and works with, that's easy to understand and what's happening there. Now, we could have just done a single relationship and put the properties of how they're related into the relationship, but that probably would have slowed you down quite a bit. We can also have multiple relationships of the same type between two nodes. In this case, a person listens to a song multiple times. Usually you watch a movie maybe once or twice, but a song you listen to again and again and again. Sometimes you don't even want to. You're in your car and the radio comes on and it's the same song again. What's been on the radio so much? Lizzo, I think, right? That's her name. The lady that does the doing your nails and feeling good. Anyway, that song is
the Australian chick.
What's that?
There's some Australian chick that's like all over the radio. She's got this like weird voice. She's great. I don't remember her name, but shame on me. I used to work in music too. I feel like I should know this stuff. Doesn't matter.
All right. Anyways,
Michael Black wants you to sing a few lines. Yano's also said the same thing. They want you to sing.
No. I'm not a singer.
Hey guys, do you want everyone to leave or do you want people to stay? That's not
exactly. Let's continue on. All right. Now, relationships can have properties, obviously. That's what separates us from the animals. I mean, the RDF people. They don't have properties in relationships. Now, they're capitulating and saying, yes, you're right. Properties in relationships makes a hell of a lot of sense. We're idiots. And we're adding this new Sparkle Star thing that lets you put properties in relationships. And now we can do what you guys can do. Welcome to the party. About 20 years late, semantic web is dead because of you. And anyway, that's a whole different topic. But anyway, we have these properties and relationships. Now, why or when do you use these things? Sometimes you use them to qualify things or quantify what's going on. In this case, you have these likes and loves, and you have two likes relationships with different strength. Which one should you use? Okay. If it's something small, like 5 values, 10 values, 20 values, that you can just break up by using relationship types, is it going to be a lot faster to use the top model where you have difference between likes and loves, especially if the relationship property is static, if it's not going to change very much. Now, if it's going to change a lot, then you're probably better off using a property and letting it change. So if someone likes someone now and then 2 months later they hate that person for whatever reason, and that strength becomes -5 or -3, then you're probably better off having a property there. Keep that in mind. Now, what about this model? We have a person who lives at an address and works at an address. Or we have a has address on the other side, and one is type home, one is type work. Which one should you use? If you listened to me 2 seconds ago, I just told you to use the one on top because we can split the relationship types and not have to look at the property underneath. But the reality is, how many addresses did a person have, right? You have a house and you have a place where you work, and that's pretty much it. You don't have a ton of addresses. I mean, maybe you're rich and have like 10 houses, but even if you're like some kind of real estate mogul, you'll probably only have like a couple hundred apartments. You don't own millions of addresses. So it doesn't make a ton of sense for you to use the top one. You can use the bottom model and it'd be just fine. So when you're thinking about modeling things, don't always say, oh, the right way to do it is the way on top. No, think about the density. How dense is this going to be? If I have to look at 2 different relationships and check one property in each to get my answer, I can just go with the bottom one. That's fine. It's not a big deal. Top one might be a little bit faster, but it might complicate my life. Then we have the parent and child of thing. I don't know why people think sometimes that the relationships are not bi-directional. They are. You can traverse a relationship from any side. It doesn't really matter. When we store it, we store for both nodes. So you don't need to have this parent of and child of. You just got to pick one. It's either going to be a child of or a parent of, one or the other.
I had a question. Can we put indexes on relationship attributes in 4.0?
Yes, but doing it the old, the weird way, using the full text indexes. So we haven't migrated relationship indexes to regular schema indexes that we have with nodes. You still have to use the store procedures to make that happen. Why? I don't know. I kind of do know. We basically don't want you to do it. Typically, when you have indexes on relationships, it's a code smell for a bad model. Not always, but most of the time. I think in the 8 years that I've been here, there's only been a few times where it made sense to have indexes on relationships. Most of the times, it was really just telling you that relationship should probably be a node and have other things connect to it. So that's kind of the reason. I have my dog whining. I think he wants to go pee. So give me a second while I open the door and let him out. Oh no, the pool people are here, and he loves going to play with the pool people. So let me open the door. All right, Tyler, go crazy.
That's perfect.
Back to business. So this obviously is fine though, and that is if you have a model like Twitter where you need to have 2 different relationships to signify different semantics, right? If you follow someone on Twitter, they don't have to follow you back. Even though you can traverse it from both sides, they really do mean different things. So in that sense, it does make, okay, they go from both sides. All right, let's go to something obvious that we've seen 1,000 times. The first lie we tell you about graphs is that they're whiteboard friendly. You get on a whiteboard, you draw your model, and voila, that's how it's supposed to work, and everything is fine. Okay, and some models are really that easy, where you can just draw it out on the whiteboard and make it work. So here's an actor or a bunch of actors who acted in movies. They played different roles in those movies, and other people directed those movies. And if we care about what actors were in what movies, this model is perfectly fine. The problem comes when we care about what characters they played, because we made the decision to make the characters a property of their relationship. So our two options here are, one, as our previous question asked, use the stored procedures to create an index on the relationships and start off by asking for the role equal to 007 and then go from there. Or another way would be to break out this model and say, okay, you know what? I'm going to have a node for the individual characters. So we can say, I want to know who played James Bond in every movie, who played Peter Pan in every movie, who played the Joker in every movie, and see the differences there, right? What's another one? Spider-Man, right? We've had like 10 Spider-Mans in the last few years for some weird reason. So it's not about getting the model perfect. It's really about understanding what questions you're going to be asking and saying, I need to match the model to the questions, not the data. Forget the data. The data can be modeled 100 different ways. It's the questions that are an important part. Now, we're going to hit this a couple of times. One of the examples I like to give also is flights. And I love flights because of a lot of our competitors copy this modeling flights idea for some of their documentation, and they totally missed the point, which we'll get to in a second. How do you model flight data, right? You model it this way with the two airports and the flying to relationship and stick everything in the property. But this is very expensive because we have to look at a lot of flying to relationships to find what we want out of them. We could have a flight node in between, which makes things worse because now you have to traverse twice as many relationships. That doesn't really help me. Another way to do it would be to realize airports have many flights per day, and people don't just fly randomly on some random day from here to there. They pick what day they want to fly out. They have a conference to go to. They have a vacation they're taking. So they have a date in mind where they want to go. So we can split out the days from the airport and say, okay, the airport has a date, and on those days they have flights. And the reason we do this is you look at something like Chicago O'Hare, they have 1,000 flights a day. So before we had 365,000 flight nodes, flight relationships coming out of that airport node. Now by splitting it up by day, we can have at most about 1,000 on each airport day. That makes the query a lot faster because we can just filter out the airport day we care about and skip all the other ones that we don't care about. And when we talked earlier about the secret of Neo4j being partitioning, this is what we're talking about. We want to look at the least amount of data to get the answer. As long as we can do that, we'll get our queries fast. Another crazy thing you can do in graphs that you can't really do in other places is use the actual dates as relationship types. So in this case, we set the airport date to be 2015-09-01, which is kind of nuts, right? You see the has day becomes that. So we can skip looking at the property of the airport date. We can just use the relationship type to go directly to the one we want and kind of go from there. Crazy idea, but it works. And we see it often in a lot of our customers' models. Another thing you can do is just get rid of it and say, forget the airports. We're just going to have the code and the date as a combined key and stick that in there. With Neo4j 3.4, 3.3, and later, we added composite indexes. So you don't have to do that weird combined thing. Now you can just say, I want to create an index on two properties and use my composite index to find that airport date quickly and kind of continue. But there's better ways, right? You can get more creative. And this is the fun part about being a data engineer, which is you can look at your problem space and say, how can I do this a slightly different way? So one other way is to say, okay, this airport day has 1,000 flights, but we don't go to 1,000 different places. We may go to 100 different places. So what we can do is break out the destinations and group them together into a destination node and then say, all right, how many are going from O'Hare to JFK? We have 30 flights. Great. Now I'm going to put a JFK destination node for each airport day, and then that destination will have those 30 flights attached to it. So that's a better model, but we can go further, right? You can say, okay, wait a minute. What if we used the relationship type, and instead of just putting a random flight or has flight or whatever, what if we took the airport code of where the flight is going to and stick it there? So we can go to any airport day and say, I want all the airport day flights that are going to ORD. And that way we can skip having a destination node. We can just go to the relationship type ORD, and we know that that flight is going to go to ORD. This helps us trim down our model quite a bit, because we can just jump to the airport data that we care about. Say I want to fly in all the flights from O'Hare to JFK. There's 30 of them. Great. I traverse 30 relationships on to get to the flight node, 30 more to go from the flight to the airport day, and I have my answer. I don't have to look at 365,000 flights or 1,000 flights, or I can just look at 30 and I'm done. And that's the fun part about Neo4j, is finding ways to look at the least amount of the graph in order to get the answer. And if you can do that, I mean, you change the game, because your queries are going to be blazing fast compared to other folks. Right? And the thing you have to get wrapped around your head is that you can bend the data to your will. You have that power. It's not a physical thing where you have to say, I have to respect the laws of physics, the laws of third normal form, and do the right thing. There's no right thing. It's what you want to do in order to get the answer fast and quickly, if that is what your application requires. So let's look at modeling Twitter really quick. You know how Twitter works. You have a bunch of feeds, and they're separated by date in descending order. One of the things you can do is look at how other databases do Twitter. And what they do is they push that tweet ID to people's feeds. So you have 1,000 followers, you're going to be replicating that data to all 1,000 followers and saying, hey, add this post ID to that list. This is how it's done in Twitter. And the one on the bottom is Firebase, which is an object database, a document database, really. Same idea, right? You're finding all your followers and you're pushing a little ID there. Now, a better way to do it is using a graph. Why? Because, well, you can just say, I follow 1,000 people on Twitter. Typically, you don't follow hundreds of thousands of people, maybe a couple of thousand at most. Otherwise, your Twitter feed becomes unreadable. And then every time they post something, you just look at, okay, find the 1,000 people that I follow and check to see if they posted something, and check the date property and order it by that. And this would work fine on day one, but it would get slower and slower over time as you have to check that posted time relationship for each one of your followers every single day to see if there's any new posts. So the better way to model that is to use actual dates on the relationship type and say, okay, find the users that I follow and tell me if they posted anything today or yesterday. And then from whatever is there, go ahead and order it by date. So at most, you're looking at 2 days worth of posts from the 1,000 people that you follow. That makes the query a lot faster and makes it more predictable as far as how much time it's going to take. And it doesn't matter if it's Twitter on day one or Twitter on year 11, it's going to be about the same amount of time, which is kind of nice. And once again, the reason for it is because of this picture, right? Because we're using the types to help us filter and partition what data we're looking for to make it fast. Now, one of the things that I don't like is that the way the types are set up, they're set up in a list, and every time you add a type, it adds it to the bottom of the list instead of the top of the list. So as you add these dates, it's actually going to look further and further down. But even if you have to look through 100 or 300 or 1,000 of these different dates, it's not that big of a deal to jump 1,000 pointers in memory until you get to the list that you want, and then go through the ones you care about, versus having to use an index or something else to find them. And this is a real change that was made by a real customer. This is from Adobe. They have a feed for a product they call Behance. They used to run this thing on Mongo, 125 servers, and the data got big. They got 20 terabytes because they're duplicating a lot of data as they're pushing out this tweets to all the followers of a different person. They decided to move to Cassandra in 2015 at 48 servers. Obviously, they had more data because they had more users, so they got a little bit big. And then in 2018, they decided to ditch all that and move to Neo4j on 3 little boxes. And since they didn't have to multiply all this data over and over again, the data size actually shrunk massively to 33 gigabytes, right? Because they realized that we were a better solution for that kind of problem. And the thing about this, though, is they don't have to scale the database. They can use the database that scales for their queries. And this is one of the big reasons why Neo4j doesn't make any money, because most of our customers run 3 boxes, and that's all they ever need, because we can handle the work. When the solution fits the need, it's magic, right? When your model and your query match, you don't have to scale out. You don't have to think big, massive amounts of data. And I know I'm being a little hypercritical because, hey, wait a minute. Didn't we just release 4.0 where we can scale out to, indefinitely to hundreds of servers and hundreds of different shards and do all that? Sure, but there's maybe a handful of customers who actually need this functionality, right? Some government entities and some big ass corporations, but most of our customers don't need this massive scale. They're pretty happy on a single box with some sizable amount of RAM. I'm not gonna lie, but still one small set of boxes in one little graph overall. Now, another thing we don't talk much about is the flexibility of this dynamic nature of Neo4j. Right? If you remember the old Terminator 2 movies, before they all started sucking, you had this guy who was able to kind of shape himself in different ways using kind of this fluid metal setup. And in this screenshot, you can see he's got 3 hands. He's flying the helicopter that's been shot at, and then he's reloading a weapon over here. So he's got 3 arms because he's not bound by our laws of how we're built. He can do whatever the hell he wants. He's fluid. He's liquid metal. So we can do the same thing in Neo4j. Instead of having this crazy hard schema of how things are supposed to be set up that no one can understand, and people just eyes glaze over as they look at it, they can say, all right, I'm going to model any form that I will ever have in any application in these 4 nodes. Okay, so I'll have my project or my application or whatever it is that I have. This project will have many forms. I don't care how many I have. It doesn't really matter. These forms are going to have fields. They can have 1 field. They can have 1,000 fields. It doesn't really matter. Now, these forms and fields are going to be filled out by people. These people are going to be included in these projects or applications, and they're going to have a value attached to some field that is in some form. And that value could be of any type. It could be a Boolean. It could be a long description text. It could be a number. It could be a float. It can be whatever you want. But with these 4 nodes and relationships, we can model any form in the entire world. It's not very hard, and you don't have to have this crazy looking model to make that happen. And this is a model that's actually being used at the startup. They do clinical research forms, and they wanted to be able to do something quickly so they can put it together without having to use what is it, like Gorilla Forms, Monkey Forms, whatever that thing is called, that startup that does this kind of stuff, or Google Forms. They use Neo4j for this stuff. And then after a while of working with this, they realized, hold on a second here. We have to kind of keep track of these people who are responding to these forms. And we want to see if they respond to the same form twice at different times, because maybe their values change, and we want to track the values changing over time. Sometimes they have to fill out 2 or 3 forms at the same time, and they're kind of linked together. They're correlated. They should really all be one big form, but we decided to split it. So what's happening here? Well, we realized then we're missing a concept. And the concept we're missing is a response. I already said it 3 times. But the idea here is now in this project that includes these people, they're going to have some kind of response. And that response can be linked to other responses. This is how a way to know if the forms are tied together. And the responses have the values, have the fields, and we can still connect everything that way. So it's a little more complicated than we had in the previous one where we just had 4 nodes. But this is a way to add that moment in time of response kind of as a hypernode that connects everything together in space. And they switched to this model in order to be able to do some of the fancier queries that we're trying to do and some of the more correlations that we're trying to do. But it's still a very simple model versus having a wall of tables and join tables that are a big mess. All right, and then we came to chains. I love chains. It's been my thing lately, right? And we see it a lot in fraud detection, in transactional stuff. Here we have a bunch of people who are using a credit card to make some transactions at some merchants. And we have an evil fraudster with sunglasses on for some odd reason who will use this credit card. And he finds this credit card number through a terminal, skimming an ATM, or just good old-fashioned data breach somewhere. They'll test it out to make sure it works. Sometimes they'll test it out by figuring out what zip code is attached to a credit card, And then once they have a valid response, they make a big transaction. This happened to me last month, where I went to a gas station I hadn't gone to before, and I used my credit card there. I guess they had some kind of skimming device on the gas station pad, keypad, and then I started seeing all these new transactions come out of nowhere. Well, they had failed a couple while they were testing out the zip code, because I was in a different area where I normally live. And then once they got the right zip code, they started making transactions, and the bank called and put a stop to it and said, "Hey, looks like you got skimmed, buddy." So it happens all the time. How do we keep track of it? How do we find this stuff? And how do we find where it's originating? Okay. Well, we can store data in a traditional sense, where you say, okay, we have this user that's making these transactions, and they just have some time attached to them, and it kind of works. This is one way to look at the data. A better way to look at the data is in a chain, where you say, okay, what was the last thing they did, and what was the thing they did before that, and what was the thing they did before that, and kind of continue it down the line. And the reason we want to see these kind of chains of data, of relationships, is because we're looking for paths where multiple things happen, where it's kind of users split apart, where things kind of combined together, where a lot of folks are doing exactly the same thing, like clusters of transactions happening in the same spot. And we've seen this in the genomic space, where people take a genome, which is just a linked list of pairs, not very interesting at all. But if you stack them on top of each other, you stack different people's genomes on top of each other, then you start seeing interesting things where everyone has the same set of genes here, and then they diverge, and then they converge again somewhere else, and like what's really happening there. And people who are sick, why are they sick? And are they prone to some diseases because they have the same clusters of genes here or there, or what's happening? Those kind of interesting queries. We can do the same thing for financial transactions. We can kind of put them on top of each other, and then say, okay, the people who have been notified of a fraud, or called us and said we had a problem, where do they have the same type of transaction? Where did they go to the same merchant? What happened? What is similar in their transaction history? And I don't care whether they have 10 transactions or 100 transactions or 1,000 transactions. Just show me everything and how they could be connected. And the examples that I've given in some of these blog posts, we find that these folks all went to the same gas station, and that's probably where their card got skimmed. Now, Robert here hasn't called in to say he's got a fraudulent transaction, but he probably will. So you might as well go ahead and freeze his card before that happens, and send him a new one in the mail, so that so the bank doesn't lose any money, or the merchant doesn't lose that item, or what have you. Now, I wanted to kind of end the canned part of this with another blog post I did on getting the latest transactions. And the trick that I did here, the user was trying to find transactions that happened, the last 25 transactions that happened to a user, but didn't want to use the linked list model that I was showing you. They wanted to just keep it separate. Fine. One idea for them was to take the node ID of the user, add it to the transaction date, and the date as a number divided by 10 million, I think it was. So we ended up with a float, and then we can use the Neo4j indexes sorted feature to find the top 25 transactions that occurred based on this index. And I thought that trick was going to be short-lived, because in Neo4j 4.0, we have these new composite indexes. And one of the things we've upgraded is now the ability to do range searches. So you can have one equality check or one range search for each predicate in the query. But I was just testing this out, and unfortunately, even though we have, here's the equality and range query that we're hoping for, it doesn't really work as far as making our query faster. So I don't know why or what's going on with it, but it looks like it's only in the ascending position, not in the descending. So it's only ordered a certain way, and it can be flipped. So our query is not as fast as our query was using the index trick that I came up with over here, which I think was, where is it, like 26 milliseconds or 1 millisecond to get our answer. This is doing it in 550. But keep an eye out for things that have changed in 4.0. Maybe some of the ways of modeling you were doing may not be optimal anymore. Maybe there's some tricks with indexes that will help you that in this case didn't help me, but they might help you somewhere. So make sure that if you haven't started playing with 4.0 that you do, and if you find anything interesting, take a look. The big change there is the ability to do subqueries using the call. So that makes some of your queries a lot simpler. Or before you had to do weird things and then collect and then do unwinds. Now you can just call it separately and then get back to it. So take a look at that stuff. And if you want to see where Neo4j is going, I wrote a blog post not too long ago called Going Faster in 2020 that talks about some of our limitations, some of our problems with the way we traverse and our speed, and how our physical layout really alters the relationships per second you can traverse. Even with this idea in your head, it's not quite exact because we do have linked lists everywhere. And then I wrote a little sample Neo4c to kind of show you what hopefully the next, maybe not 4.1, maybe 4.2, but somewhere in the line of the 4.x, we'll be able to change the way we store these relationships to make them even faster. And now I'm not expecting to go 40 times faster than we are now, but we should be able to get at least 10x. That's what I'm hoping for from our developers within the next couple of versions of Neo4j. We shall see. If not, we're switching the entire company to Neo4j for C, and we do things in a slightly different way. Anyway, that is my canned stuff. Let's talk about questions you may have.
So we do have the ability. So Lavanya had, I hope I'm pronouncing it properly. We do have the ability to put their microphones on, like the attendees, if they want to ask live. So if you do, I guess you could just put the little hand icon, and then I'll turn your microphone on, and we could just go through it. Lavanya, do you want to ask the questions live, like so you can go back and forth, or you can write in the regular chat if you have a preference. And then Saeed also, I hope I'm pronouncing that right, and I'm sorry. Okay, so Lavanya's going to ask questions live. So I'm going to put her microphone on. That way she could, elaborate on the questions she asked. So, all right, I think that, okay, so, oh no, I think Lavanya, you actually have the ability to turn your microphone on yourself, I think. If you go to the top bar, there should be like a little microphone button. And then if anybody else has any other questions too, you can, just put your hand and then you can ask, you can turn your microphone on, or you can just ask in the Q&A section.
Okay, well, she figures that out. I can look at some of these questions and kind of just go backwards.
Yeah, Saeed is one other one too that just asked a question too.
Okay, well, Saeed's one is easy. It's not a bad idea to have or conditions. It's not really or. It's really...
Do you want to repeat the question just so?
Sure.
Over the recording.
So the question is it a bad idea to have or conditions on relationship types in your Cypher query? So something like a follows pipe likes. So you're looking at both the follows and the likes relationship types. And why is this going to be deprecated? It's not going to be deprecated. What happened was we are forcing you to put colon in front of the follows and likes. So the ability to just do the pipe is not going to work. So in other words, this is going to have to be written as, let me paste it into the chat here. So you'll have colon follows and colon likes. So it's not really deprecated, it's just we're changing the way we're forcing you to do it. What happens is the node now has to look at two relationship types, but if two were the actual right thing to do, that's fine. It's better to do that than do something else. All right.
Lavanya's here. Can you hear us? Am I pronouncing your name right?
Yeah. Do you hear me now?
Yes.
This is Lavanya.
Hi.
Okay, you're pronouncing it right. I'm actually called by Lavanya in India, but I'm used to Lavanya in the US.
Lavanya. So, I like that better.
Okay.
I'm not new to graphs. I have a graph theory degree back from Texas, and I'm new to Neo4j though. So my questions might be very simplistic, if you will. But I typed all of them in the Q&A.
Okay, so let's take it to the top then. the first thing you ask is about writing our own graph algorithms in the Neo4j platform. Okay, so there's two things here, I guess, really. One is we let you do your own graph algorithms if you want using the Neo4j Java API. And you can do whatever you want there, but it's going to be using the Neo4j data structures and the Neo4j layout in memory, which is this multi-relationship type kind of layout. So it's not the fastest thing in the world for some of the algorithms that exist out there. Now, you have probably seen the graph algorithms library, and the new one is called the graph data science library. I forgot the name. We're changing the name. That should be out in beta now, and I think the final release will be in April, if I'm guessing correctly. Those both run on in-memory graphs that are not the Neo4j data structures, but their own custom data structures. And I think the first one that was built used 2 or 3 different layouts. I'm not sure if the one we have now it just uses a single layout to run the algorithms. These are going to be open source, so you can see how they did the work, and you'll be able to obviously modify it to whatever you want. Right now, we only have a couple dozen algorithms that we've written that you can use. But if you want to try your hand at this thing is missing, or we're missing the weighted version of this algorithm, if you want to add those, I'm sure you'll be able to do it. It's going to be more hardcore, obviously, than you might be used to, because it's not something we talk about much. It's barely new, right? It's only a few months old. Neo4j has been around for 20 years, so a lot of the stuff we've seen them done 100 times over. This stuff is all fairly new. Okay. The second question you asked about hypergraphs. There is no trick. You really have to create a second node. There is a blog post, a video from Marvel Comics. Have you seen that one already?
Yeah, I did.
Okay, so the way they do it is a hypernode where it becomes an instance in time, or in this case, they call it a moment in their video, where you have a time component attached to it, and it basically you attach everything to that node, and then you kind of go from there. There is no other real way of doing it. This is just kind of what makes the most sense, and using
that blog post was interesting, and it actually connected, made me look into some of my old graph theory texts. And there is actually a theory that links hypergraphs to what is called bipartite graphs, where the nodes are on the hypernodes, or the nodes of the hyper graph are on one side, and the hyper edges are on the other side, and then the links are placed accordingly. So I feel that the blog was kind of inspired by that that relation from that text. But that's why I feel that placing an auxiliary node and connecting it to the nodes that belong to the hyper edge is one interesting way. But it took me a while to understand how one can model it themselves. So I was wondering if there is a way we can Neo4j can let the users know how hyper edges can be modeled if they specify the bipartite graph. Maybe there is a way that we can suggest modeling graph models that can be used. But anyway, that's a long shot.
Yeah, I mean, we've stayed away from telling people how to model data. It's more like, here are the options you have, and then pick what best works for you. Because even when we have customers who look like they're the same, they're 2 credit card companies or they're 2 banks, and they're looking at the same data, you'll still find that they use different models because they have different ideas of how to tackle the problem, or different constraints in their environment about what they're doing. So it's hard to say this is the right way to model network infrastructure, or this is the right way to model financial transactions. It never works out that way. It really becomes what are you trying to do, and go from there. Okay. And then you asked another question regarding huge graphs and cipher projections.
Yes, I'm asking this in particular because I saw some of the algorithms that are implemented. Some of them are implemented for huge graphs. But if we want, for example, the direction version of that algorithm, uh, we are asked to switch to the cipher version. And I didn't know if which one to use when, and which one is ideal to use.
Okay, so you're talking about the graph algorithms library. The cipher projections are just a way to get, basically to convert your data from a multiple relationship type, multiple node type, multiple whatever type into a simpler graph that the graph algorithms library can understand. Because the graph algorithms library doesn't have multiple types.
Mm-hmm. I see.
At least it didn't in.
That makes sense for an algorithm.
Yeah, so it's like another way to say, okay, I have this relationship that goes through a hyper node, hyper edge in the middle with a separate node, and I want to kind of compress it into a simple relationship between two nodes, and then use that as part of my in-memory graph to do my queries. And we've seen this a lot in financial transactions where you have a user that's tied to a transaction that's tied to a credit card, and sometimes you don't really care about the transaction, or sometimes you don't care about the credit card. You really want to go from user to one or the user to the other. So you skip the thing in the middle and you just connect the outer edges. So the cipher projection lets you have whatever model you want for Neo4j, and then convert that into a simpler model for the graph algorithms library. Now the huge graphs are just that's just a setting on a different way to, I think, map your data in memory. But they're totally unrelated to the cipher projection. It's just how big the thing is. Okay, let me see other questions. We use Mike Bloom.
We have two questions in the regular chat. I don't know if you see it. So one was Mike Blum was asking about a blog post.
Yeah, we have call and collect with. Yeah, collect with is it was the old school way of doing call, basically, like the old school way of doing subqueries, right? Do this thing, collect it all, keep it around, and then do something with it later when you need it. Do we have any blog posts on this? Not yet. They should be different. Well, what's going to happen is with the call, you're going to be doing almost like a separate traversal really on the side. So it might take a little more memory, but not much more than kind of keeping the results of the collect and with anyway. So I'm guessing they're going to be comparable as far as performance, but that's an interesting thing to look at. Paul's question disappeared. Oh, he brought it back. Okay. How can I identify which parts of my Neo4j data structure would be most benefit from some data model analysis? I know I could do an explain a particular query, but it may be difficult to know which queries I should be investigating. Okay, well, a couple of things is if you're already running real queries with real data, in other words, you pass the building stage and you actually have something running, you can turn on query logging and set a threshold, say 3 seconds or 5 seconds. And anything slower than that, those queries are going to be picked up. And you'll say, okay, any slow queries, I'm going to go ahead and analyze. If you have tons of queries, especially, let's focus on the ones that are slow. Another way to do it is just use the explain and the profile. So don't use explain, because explain can get it wrong. I would always go with profile. Profile tells you the real deal, like what actually happened, how many nodes, how many relationships did it actually look at to get the answer. And worry more about the time than you worry about the DB hits. DB hits are not exactly all measured equally. It's the time that you're focused on. But while you're there, you say, okay, what is this thing doing? How many rows is it bringing back? Are we doing something twice where we can eliminate it? There are other ways to kind of analyze a traversal and see what's happening. I have my dogs over here coming to say hello. And if you get stuck, just ping us, give us a call. I mean, I love going through models and tearing them apart and rebuilding them, or maybe just tweaking a little thing here and there and to see what we can do to make it better. We have tons of experience with models. We've seen thousands of them. So don't be afraid to pick up the phone and call us. You guys know my number is public, and so is my Skype. And
he's also in the community Slack too. It's like, everybody's.
Yeah, if something that's private, use private messaging. If it's something that you don't mind sharing with the rest of the community so we can all learn from what you're trying to do, then yeah, use the
well, there's also private messages on Slack user group.
Yeah, use the form.
can,
Okay, Mike asks, would indexes still be used within a call? Yes, it's still going to be just like a normal separate, isolated transaction. So it's nothing too crazy.
Saeed also had another question in Q&A. Is there any plan to add profiling capability to APOC calls? Sometimes APOC calls let you have much simpler queries, but you want to make sure it still performs fine.
Okay, so nothing planned, I guess I would say. I mean, this is obviously Michael Hunger's baby. So some queries probably easy to profile, and some of them have some statistics so you can pull back and see how much it did and how much work it did, how many retries you had to do. So there's some that have already kind of some tracking attached to them. Most of them don't. Easy enough to add if that's really something that's bothering you or is slowing you down. Also remember, it's just code. So you can just grab that APOC function, bring it into IntelliJ or your favorite Java development tool and just literally run it and see exactly what it's doing and maybe figure out what it's doing wrong or what don't you like about it, and then changing it or building your own, or maybe finding a way to make it better for everyone and sending a pull request. And Michael loves getting pull requests on APOC. So if you have a better idea of how to do something, by all means.
Yeah, he loves suggestions too. He definitely welcomes it. So if you want to, you can always post in like the Ninjas chat group because he does also look at that, but you can also send him a message.
Suggestions are nice, but pull requests are better. If you do the work, you just give us a code.
Paul wants to know if you're going to be at Graph Connect 2020.
Yeah, I think we all have to be there.
Not everyone, but a big chunk of the company. Max will definitely be there. He's a seasoned Neo4j-er. He could do whatever he wants.
Yeah, I mean, I'll be doing some of the training. One of the things you get out of coming to Graph Connect is you get half the company to talk to. So if you want to corner Michael Hunger and basically not let him go until he builds a feature for you, you can do that, right? If you want to grab hold of Mark Needham or William Leon and say, I want this thing in GraphQL, goddammit, and I want it now. Well, you can kidnap him and make him code it while you're there, if you so choose to do something as evil as that. But you have access to us right then and there. Or if you have something where you can't really share in the public forum, that's fine. But also, don't forget, you guys are free to email us. You guys are ninjas. So Max at Neo4j.com, Michael at Neo4j.com, Mark at Neo4j.com. Those are going to go right to people in DevRel or myself. I'm always open to emails. Some people, not so much.
Yeah, Michael sometimes it gets lost in he's got a lot of emails that come in. So like sometimes it's better to just message him on Slack, I think. Yeah. Right? Or you could always ping me and then I'll make sure that he sees it.
Yeah, because you don't get a lot of emails. That's fine.
Oh, I mean, I do, but I have my own way of organizing it. Does anybody else have any other questions before we say goodbye to Max? You can put the little hand up if you have a question. That way you give you time to write it out.
Yeah, another thing I'll tell you is don't be afraid to ask for help. I mean, this is fairly new stuff. I know I say Neo4j is 20 years old, but really it has only gotten mainstream attention in the last few years. And some of the stuff we're finding out with you what the best way to do something is. So if you come up with something crazy that we haven't seen before, I will really appreciate, because that way I get to learn something new and hopefully help you, make a better product, make a better, whatever thing you're playing with. And then hopefully blog about it and get the rest of the community to learn from it. So don't be afraid to ask for help. The worst thing you can do is run into brick walls and continue to run into brick walls without asking for help. Just don't be stubborn. Just say, hey, is there a better way? Have you seen this before? How can we do X, Y, or Z? Let us know. We'll figure it out together, worst case.
Cool. Lavanya has another question, and then Michael Black says thank you. He says he loves seeing various models, and repetition of seeing problems you've solved as a field engineer helps them learn. And Dave said ditto.
Yeah, I'm glad somebody reads that blog post, really.
Look, Dave said he was only going to make it for the first half of the talk because he's still here. Lavanya, do you want to ask your question? You can turn your mic on if you want, or you could just type it out. It's up to you. And if anyone else has any other questions, you can raise your hand. And thank you guys so much, by the way, for being so active in the community, because it means a lot to us to have you guys helping us.
Yeah, QA, I think that's
okay. So Lavanya said she posted a bunch of questions to the online community, and how can she expedite answers?
Good question. You can always send flowers or chocolate to Michael Hunger and ask him to go through them. I don't know. I think make sure you're posting in the right topic. Make sure maybe you ping the people who are most involved in that topic or who may know the most. Also, got to remember, a lot of our folks are European. They have lots of vacation time, so they might be out skiing for a couple of weeks, or who knows what. But hopefully, somebody will be able to answer your question. If you get stuck, just ping people. I mean,
you can also post your questions in the Ninja Slack group too. You know, like part of the idea of the program is that we all kind of help each other, because there's a lot of people who are doing this as seasoned people, and you know, we could definitely utilize that. So if you feel like you're not getting a question or you want something, you know, post it on the community site, and then you can always ask the ninjas. And in the ninjas group, actually, one of the things we told to some of our internal engineers is that if our ninjas do need help answering questions, that they will be there to help them. Mike, if you send me a message on the Neo4j Slack, just send me like a little note. I'll add you into the group. So most of the time we've been asking people for their Slack username, and if I haven't been able to find them, I'm not getting added. But if any of you guys need to get added, just send me a note message on Neo4j Slack, and I'll add you in there. So that's it, I think. Good. If anybody else, this is the last time you could do the hand raise. Oh,
that's my baby Tyler.
Where's the dog? Jumping on people. All right. Thank you guys so much. Really, I really appreciate you guys like being involved and, you know, being hungry for more knowledge. And if you guys have ideas on like how we can make this program better, like what you'd like to see, like seriously run anything by me. Like we can always talk about ideas, and the best way for us to build like community programs that are going to be valuable to you is if you tell us what you would like to see or what you want more of, you know? So yeah. Thanks, Max. Thanks for your help.
Take care.
All right. Bye, everyone. And we'll send a recording out to you guys, all the people who participated. Bye.